But why build another space station? Mir had gotten too old. The United States, Russia, and other countries wanted a larger, longer-lasting facility to do long-term research in space. The space shuttle had supported some research, but flights had been too few and too short. A bigger space station and also would provide better research support services, such as data transmission, than the shuttle could ever provide. The 16 partner countries equipped to support for the International Space Station are the United States, Russia, Canada, Japan, Brazil, Belgium, Denmark, France, Germany, Italy, the Netherlands, Norway, Spain, Sweden, Switzerland, and the United Kingdom. The £1 million International Space Station is the largest construction project ever attempted in space. The purpose of the ISS, the purpose of the International Space Station, has several purposes. One of the most important is that ISS provides a constant presence in space. Since November 2000, there have been from 2 to 13 when the Space Shuttle orbiter was docked, astronauts and cosmonauts at a time living in space on the International Space Station. Rather than spend a few weeks in space, astronauts and scientists can stay for 3 to 6 months to study the effect of weightlessness on the human body and to do experiments in microgravity. The research done aboard the International Space Station may lead to breakthroughs in medicine, engineering, technology that will have practical uses for humanity on Earth. The research could create jobs and economic opportunities tomorrow and in decades to come as investment in the future. ISS provides ways to do research that cannot be done on Earth. With its view of 85% of the Earth's surface, ISS can help us observe and understand changes in the environment and our impact on the planet. By exposing materials to the harsh environments of space, we can learn how materials are affected in order to better design future spacecraft. The International Spacecraft shows how countries can work together for peaceful use of space. We can accomplish greater feats like crewed mission to Mars with operations rather than competition. Also, the lessons we learn from building and operating ISS will prepare us for future manned missions and space exploration components of the International Space Station. The International Space Station is made up of cylinder-shaped modules and other large parts that are built on the ground, then assembled and maintained in space. The station was designed to be expanded. The first piece, a central control module named Zarya Sunrise, came from Russia and was put into orbit by a Russian rocket in November 1998. Zarya was docking port for additional modules and solar arrays for power. The second piece was Unity, which is a space shuttle carried into orbit on December of 1998. As the name suggests, Unity is a small module that allows 6 other modules to be connected together. The ISS became a working space habitat when the third piece, the service module, Zvezda Star from Russia, was attached to the station in July 2000. Zvezda provided living quarters and life support systems for the first few crews. Destiny, a U.S. laboratory, was delivered in February 2001. The scientific research aboard the station could now begin. More components have been added, with 15 pressurized modules as well as a number of unpressurized components making up the ISS. The central girder or truss, which is a set of long beams fitted together, connects the modules and the main solar power arrays. The truss provides a rigid framework for the station. Various countries are providing other pieces of ISS space station. The space station remote manipulator system provided by Canada is a 58-foot-long robot arm that helps with assembly and maintenance. The arm travels along the truss on a moving platform. 4 solar arrays, which provide electrical power, rotate on the truss to stay facing the sun. The 6 large radiators provide cooling in pressurized areas. From Italy and Brazil, have come cargo containers. The Quest air block from the United States allows crew members to conduct spacewalks, and an emergency crew return vehicle, Soyuz spacecraft for every 3 crew members, is always docked at the International Space Station while it is inhabited. This assures safe return of all crew members if a hazardous situation, such as a fire or loss of pressure, occurs on the space station, and a quick departure must be made. The construction of the International Space Station was largely completed in 2010, resulting in about 1 million pounds of hardware in orbit assembled during the 33 space missions, with more than 150 spacewalks over a period of 13 years. The International Space Station will be orbiting through at least 2020 and will be deorbited into the Pacific Ocean. When its operational life is complete, the International Space Station is the largest structure ever built in space and has honed and perfected our skill at assembly, maintenance, logistics, and international cooperation on scientific and technical endeavors. The use of distributed power and cooling systems, the repair of the solar arrays and rotary joints, and the recycling of water and air for life support are good examples of what we learned that could help us as we explore the solar system and establish homes in space. The International Space Station flies over 85% of the Earth's surface and 95% of Earth's population, and is as bright as Venus. To find out when the International Space Station is visible over your location, see the resource section. An airlock is a small room with one door to the pressurized area and another door to the outside, a vacuum. A control panel allows the crew member to release air out to space, after which the door to the outside can be opened and the space-suited crew member can exit the station on a spacewalk. When the spacewalk is finished, crew members re-enter the airlock and another control pumps air back into the airlock until the pressure is equal with the interior of the space station, after which they can re-enter the station.